Hi everyone, action time. Grade 11 physics, past paper questions. So we are going to carry on with our questions. Last lesson from 1 year just past paper question. We have done question 1, multiple choice questions, and question 2, mechanics questions we have done. Today we are going to carry on with electrostatics. Question 3 we are answering with you. But before we start, reminder for you, please go to PDF video link and get your question and try first. All right, please try first, and then you can see all answers on this video. So question 3, what they ask, let's see. We have two spheres, two identical metal spheres, A and B, with charges 4.4 pc and -2 pc. If we have these two charges, let's see what they ask. Which sphere has more electrons, A or B? That's our question 1. So let's see what they ask. Yeah, what's our answer? B. Answer is B. They're asking you which one has more electrons. Of course, B has more electrons because B is negative. B is negatively charged. Negatively charged means more electrons. 1 mark we have. So let's continue. The spheres are allowed to touch, allowed to come together and separate. So they are touching each other and separating. So what's going to happen now? They are going to have same charge. We know that. Let's see what they're asking. Will the spheres attract or repel each other? All right. What we know, they have same charge after touching each other. If they have same charge always repel each other. So that's our answer, people. They repel each other because they will have same charge. I hope all okay for now. So we are going to carry on with next question. Now, calculate the charge on each sphere after they have separated. Calculate the charge on each sphere after they have separated. Now we are looking for new charge after touching each other. What formula we are going to use? Of course, Q final equals Q1 plus Q2 over 2. We are adding them and divide by 2. Add and divide by 2. You are getting final charge after separation. So 4,4, first one, QA, QB also you can say it's fine. 4,4 plus -2 over 2. You are getting 1.2 pc, pico coulomb. You know pico, 10 to the power of -12. So we are going to convert it to coulomb now. Let's see. I hope all okay for now. If you have any question, you can ask on comments. You can ask anytime. So next one, calculate the number of electrons at charge B. So calculate the number of electrons at charge B. How can we calculate? We are using a formula. Q is equal to N times QE. N times QE we are using, but Q charge is negative, so we must just convert it. So we must just use negative first, -1, -2 times. As you know, it is -2 times 10 to the power of -12. And this is also negative. And we must just change it. So final answer will be positive. Please remember that. Okay, we can carry on. So quickly, let's go to that question back. So first of all, -2 times 10 to the power of 12. So charge B, we are writing in coulombs, and charge of electron, QE is charge of electron, -1 times 10 to the power of -19, and you are getting number of electrons with 1,25 times 10 to the power of 7 electrons. Okay, we have done this question. Calculating number of electrons, as you see, we are using charge equals NQE formula. Okay, we have done. We are forgetting this -2, but we add now. All done, all okay. So next question. Let's see what they ask now. We have Q1, Q2, Q3 now with distance 40 millimeters. One more time, they are asking you with picocoulombs. All right. First question is, state Coulomb's law in words. Okay, asking you what is Coulomb's law. Coulomb's law is coming now. The electrostatic force between charges is directly proportional to the product of charges and inversely proportional to the distance squared. So this principle is known as Coulomb's law. This is our answer, but we add just some extra information here. So this is our first sentence is our answer. Electrostatic force between charges is directly proportional to the product of charges and inversely proportional to the distance squared. So from this formula, you can get, this is our answer, first sentence, but let's explain more. Force equals K times Q1 times Q2 over R squared. So K is Coulomb's constant. It is constant number. We are going to use it when we want to calculate force between charges. And Q1, Q2 charges, amount magnitude of charge, and R is distance in meter. Distance in meter. If it is not in meter, you must convert it. And then units. So if you see MC, millicoulomb, 10 to the power of -3, you will write. If you see micro, 10 to the power of -6, you will write. Nano, 10 to the power of -9. Pico, which one we are using now, 10 to the power of -12. And kilo, small k is much, just small k we are using, or kilometers, yeah, or capital, yeah, capital is one. Kilometers, 10 to the power of +3, and giga, just 10 to the power of -9. So this is our Coulomb's law. 10 to the power of -3, all units, everything here, but you are going to write only first sentence, not everything, of course. But these units, we should remember these units because sometimes they are going to give in millicoulombs, micro, pico, nano. So when you see NP to these letters, you must write 10 to the power of -3 or 6 or 9 or 12. So you must convert it. Okay, we have done. Let's continue. Now, calculate the net force acting on Q3 because of Q1 and Q2. Okay, so we are going to calculate F net on Q3. F net on Q3. We can draw our free body diagram first. Okay, let's take on the for object on the diagram we can show first. You have positively charged object and negatively charged object. What we know, if you have positive and negative, they attract each other. So this is our direction of F2, not 1, F2, 3. So from 2 to 3, force, it's our first one. And second one, it is negative, this is positive. So also attracting this way, let's say F1, 3. And then how can we show our net force? Okay, let's draw a free body diagram for Q3, and then we can show net force direction also. This is our first force F2, 3, and then we have this way F1, 3. Of course, direction of net force, we are using this method, and then this is our F net. So we are going to calculate it because they said calculate. So net force acting on, yeah, we need with direction because they didn't say magnitude. So they said net force acting on charge. So F net we are going to calculate, but what's the direction of F net? As we see, south, east. When we're done, we can write it down. All right. So let's calculate F1, 3 first. F1, 3 from 1 to 3 charge. We are calculating K times Q1 times Q3 over R square. Which R we are using? 1, 3, distance between 1 and 3. We are using this distance. Let's continue. K is equal to 9 times 10 to the power of 9, positive 9, we know that. And Q1 is equal to 6 times 10 to the power of -12 because it is pico. Coulomb. You must convert to Coulomb. And what is Q3? 4. Negative 4, but we are not using negative positive. Negative positive just helping you to show the just direction. So we are using only 4 times 10 to the power of negative 12 also. That's also pico. And distance. We said we must use in meters. 40 millimeters, how many meters? Divide by 1,000. So 0,04 meters. And this one also, let's convert from now, 0,02 meters. We must use in meters to get Newton, force in Newton. So we can use 0,04, and then we are just getting F13 equals, when you calculate it, you are getting 13,5 times 10 to the power of negative 11 newtons. This is our first force. And second one, this force on Q3 because of Q1. Now we are calculating, now we are going to calculate F23 we are going to calculate now. So let's just change color. So F23 is coming now. F23 equals, formula same. Please don't forget to write formula. For each step, we should write formula to get full mark. So Q2, Q3, and then R23 square. So we can write all numbers first, and Q2 is equal to 12. 12 times 10 to the power of negative 12. Q3 is equal to 4 times 10 to the power of negative 12. And distance now is 0,02. So we have done. Now we can write our answer to F23 is equal to what we are getting, 108 times 10 to the power of negative 11. So this is our second force, but we are looking for net force. How can we calculate net force? F net equals, because they're perpendicular, so we can use F net is equal to F net equals F13 square plus F23 square, and then you can say equals, using our numbers, what we have, 13,5 times 10 to the power of negative 11 square plus what we have, 108 times 10 to the power of negative 11. Let's make it longer. And when you calculate it, you are getting 108 times 8,4 10 to the power of negative 11 newtons. So 108,84 times 10 to the power of negative 11 newtons. This is our answer. As you see, how we are calculating, first of all, we are calculating force between 1 and 3, Q1 and Q3, and then calculating Q2 and Q3, and then you are using this formula to calculate F net. And what about direction? Southeast, we can see in our free body diagram already, direction is southeast. Okay, we have done this question. So let's continue with next question. Let's see what they ask. Define electric fields at a point inwards. Okay, just like Coulomb's law, let's give more details for electric fields. So electric field is a region in which the electrostatic force can act. So this is our definition. And then what we know, electric fields for positive, always from positive, just repulsive force, repulsive electric field we have, negative always attracting all. So when you calculate electric field, you must just use this positive repel and then negative attract. Just remember that. Okay, let's continue with next question. Let's see what they ask now. Draw the net electric field pattern. So, okay, we are going to draw electric field pattern between Q2 and Q3. All right. What we know, from positive to negative. So it's going to be like this. from positive to negative, from Q2 to Q3. If they ask you another one, Q3 and Q1, from Q1 to Q3. If they ask this one, so we are going to draw, they repel each other. We must just show they repel each other. So now this is our answer. So from positive to negative, we have done. All right, let's see. I think we have done now. Yes, we have done all for today. See you next lesson. Have a nice day, everyone.